Okay, we're right near the end of chemistry now. You guys already know a whole bunch about the periodic table. You know how to make compounds. You know how to name compounds. You already know how to tell when a chemical reaction occurs. You now know how to tell what type of chemical reaction is happening. Now what you need to know is how do you speed those up and how do you slow them down? So can you change the rate of the reaction? And the answer is yes, you can. And today is figuring out how you do that. So the whole reason why you can change the rate of reaction has to do with the collision theory. The collision theory states that for a reaction to occur, particles must collide with the correct orientation and sufficient energy. What you need to know in grade 9 isn't the orientation and isn't whether or not it has sufficient energy, but that they have to hit each other. And we want to know, how can you make those collisions happen faster, but also how can you make them happen slower? So both of those are really important questions. So how can you do that? If you increase the number of particles available to react, you should be able to increase the collisions. And you can do this by increasing the concentration. More particles there to react, more collisions will occur. You will speed up the reaction. So if you have more particles there, the reaction will go faster. If you want it to go slower, you can decrease the concentration. That's the opposite way. If you can't increase the concentration because you don't have any more, you could increase the pressure. Now, this isn't always easy, and often you need to have a lab to do that, but you could increase the pressure of the reaction, causing the particles to be closer together and therefore forcing more collisions to happen. So pressure can also be something that changes the rate of the reaction or how fast your reaction happens. Higher pressure, more collisions, faster reaction. Slower, you want to decrease the pressure, less collisions, slower reaction. Works both ways. Temperature is another way. Now, collisions happen when particles are moving around. So if they're moving around a lot, you're going to get more collisions. So if you increase the temperature, you increase the kinetic energy of the particles and therefore increase the number of collisions. If you've increased the collisions, you've increased the rate of reaction. Higher temperature, more collisions. Well, higher temperature, more energy, more collisions, faster reaction. Lower temperature, slower particles, less collisions, slower reaction. Catalysts are a different way. So catalyst is taking something that will cause the reaction to happen and then, but it doesn't actually affect the reaction at all. It just makes it happen faster. So there is a video on me using a catalyst to show you how this reaction happens, but it just speeds up the reaction. So it decreases the amount of energy needed for that reaction to occur. You add the catalyst, you get a faster reaction. So enzymes are a type of catalyst that are used in living organisms. If you want to use a catalyst, catalyst literally means to unite in Greek. So you use the catalyst, you have a faster reaction. Now, I'm always telling you about the slower reaction because sometimes you want to slow things down. When you want to slow it down, you don't use a catalyst, you use an inhibitor. Inhibit means to prevent. So if you use an inhibitor, you prevent the reaction from happening or slow it down. So there's one going both ways for all of these things. We don't just speed up reactions, we can slow them down as well. Surface area also has a big difference. You guys know this because if you do, I always think sugar cubes and just powdered sugar. If you put a sugar cube into hot water, it will take longer to dissolve than just powdered sugar because there's more surface area with powdered sugar. So therefore it'll dissolve faster because there's more surface area. If you have a solid cube, it's going to take longer to dissolve, which is why you tend to stir it, because when you stir it, you're changing a whole bunch of other stuff as well. You're actually making those collisions happen. So if you want to increase the surface area, you will increase the number of particles that are exposed and increase the collisions and therefore increase the reaction. If you want to decrease the reaction, you want to have less surface area, and that will slow your reaction down. So that's why all of your powdered drinks are powdered, so they mix in faster, especially if it's a cold water drink. They put it into powder because then it will dissolve faster. That is how you speed up and slow down reactions. And you're all set to go.